Welcome back, my dear friends, and again, welcome to Easy Civil Engineering. My name is Shubham Lakhera, and I welcome you into my engineering world. This is the fourth one topic from these 10 topics from civil engineering. Subject name is Fluid Mechanics 1, and in this particular video, we will be studying about steady, unsteady flow, uniform, and non-uniform flow, which is a topic from kinematics of flow. So let's study that. Friends, before I start telling about uniform and non-uniform flow, steady and unsteady flow, before that we should know about what is actually fluid kinematics. So in fluid kinematics is a branch of engineering science that describes the geometry of fluid motion in terms of displacement, velocity and acceleration, or any other quantity that can be derived from displacement or time. So what do we actually understand by this particular branch of fluid mechanics, that is fluid kinematics? This is one special branch which describe the geometry of fluid motion in terms of its displacement, its velocity and acceleration. Means to say, in this particular whole unit, in this particular whole subject, you will be studying about how fluid geometry is affected by how fluid is flowing by its displacement, by its velocity, by its acceleration, and by any other quantity which can be described in form of displacement and time. So this thing relates in fluid kinematics. So now we know that what we have to study in fluid kinematics, or what actually fluid kinematics is all about. Next we are let us come to our point that what is steady flow and unsteady flow. So in this particular definition of steady flow, this definition is of steady flow. In the next slide I will be showing about the definition of unsteady flow. So what is actually called steady flow? If the fluid and flow characteristics such as density, velocity, pressure, acceleration, etc. at a point does not change with time, then the flow is said to be steady flow. So first of all, my drawing is pretty bad, so I have just tried to demonstrate using just drawing some sort of pipes and given an example. I'm not much good at drawing, so my bad. But as you can see in this particular figure that I have shown you by two pipes are here, and in first pipe there is a density, pressure, acceleration at a point. Means to say, these four characteristics: fluid density, fluid velocity, fluid pressure and acceleration at a certain point. Just you can assume any point in pipe which is left side, and at that point the density of the fluid, the velocity of the fluid and the pressure of the fluid and acceleration at that point, it is at the same point. At the same point, after some time, as you can see in the other pipe, it is not changed. Means to say, suppose select one point in which density, pressure and velocity or acceleration, these quantities are not changing with time. Means to say, they are being constant, then that is called steady flow at both of these pipe. Because in first pipe I have shown that at some point density, velocity, pressure, acceleration, and after some time if these are not changing, because these both are same in this particular figure, then this means to say flow is steady. The same you can assume with any another example. For example, you are doing gardening and giving water to your trees. If the density of the fluid, velocity of the water, pressure and acceleration is not changing from at a point with respect to time, then that is called steady flow. So next let us know what is unsteady flow. So if the fluid characteristics if the fluid and flow characteristics such as density, velocity, pressure, acceleration, etc. at a point does change with time. Mark my point, does change with time. The flow is said to be unsteady flow. So very simple and straight definition: steady flow is a flow in which these four characteristics of fluid such as density, velocity, pressure and acceleration, if these are not changing, that is called steady flow, and if these are changing, that is called unsteady flow. In this figure you can also see that there is one pipe in which at a point we have some sort of density, velocity, pressure and acceleration, but after some time at the same point the density, velocity, pressure and acceleration, these are changed, then this means to say the flow is unsteady flow. Oh, so friends, next is example. Next, let us know what is uniform flow. So, if the velocity vector at all point in the flow is same in magnitude as well as in direction at any instant of time, the flow is known as uniform flow. What does it mean? Just look at the figure. In the figure you can see that consider each line, each dashed line as a streamline. So by seeing that figure we can easily pretend that streamlines are quite parallel, there is no any disturbance in the fluid, and direction is also the same. So this is an example of uniform flow. So the definition arises with the same, that if the velocity vector is same at any instant of time in any at any point, then within the fluid, then that is called uniform flow. Okay, so now this might be the last definition of our this video. In this we will study what is non-uniform flow. So what is non-uniform flow? If the velocity vector varies from point to point at any instant of time, the flow is known as non-uniform flow. So you can see in this particular figure where their velocity is not equal, somewhere the velocity is less, somewhere is light, means to say by using different types of lines I have tried to give an example that within a flow of pipe or any flow, if the velocity is changing or it is not constant with respect to time or at any instant of time, then that is called non-uniform flow. And secondly, you can also define using streamlines, that if streamlines are not parallel, they are disturbed, then you can say that the flow is non-uniform flow. So our this video ends here. Thanks for watching. Do subscribe to my channel to get updates about my new videos, and watch next video, which is on our next topic, laminar flow. See you soon. Thanks again. This is Shubham signing out.